Hey guys, Mr. Garcia here. And the answer for question number 10, the definition of a function is that every input has an output. Okay, so for example, number 11, this is a function because every single one of those inputs are different. So negative 4 corresponds to 3. This is a different number. So every input is different. Every input has an output. This is a different number. They're all different numbers. We're not repeating those. So if we were repeating, an it would not be a function. If we could repeat it, but every time you see, like for example, if we see a negative 4, if I write negative 4, it better corresponds to 3 every time. Okay, so negative 4 should always correspond to 3. Every input has an output. Okay, so this is a function because negative 4 corresponds to 3, negative 4 corresponds to 3, negative 4 corresponds to 3, and all these numbers correspond to uh, their own output. So none of these repeat. All right, so this is a function. Okay, what about number 12? Question number 12, the reason is f of 6 is equal to 9 because anywhere you see a 6, you're going to replace it with 6. So anywhere you see an x, you replace it with 6. So let's do parentheses first. 9 minus 6 is 3. And 3 squared, that's 3 times 3. 3 times 3 is 9. Okay, so that's question 12. Question 13, f of 49. So this is a function. So we have, that represents a function. That's why we put f or g or h. So this is a function. So anytime we put a f of 49 is always going to give us negative 5. All right, so let's see. The square root of 49 is 7. Okay, so 2 minus 7 is equal to negative 5. So this is a function because every time I put 49 for x, I'm always going to get negative 5. Okay, that's number 13. Number 14, this is a function. Every time I put a 4 for x, I'm always going to get 7. Okay, let's see. 5 plus 4 divided by 2, half of 4 is 2. So 5 plus 2, that's equal to 7. So every time I put 4 for x, I'm always going to get 7. So f of 4 is 7 for slide number 14. For slide number 15, this is probably the hardest question on there. Okay, so let's see. The reason is 64. So this is a ball being thrown straight up from the top of a 64-foot tall building with an initial speed of 48 feet per second. So whoever throws the ball 48 feet per second, that's kind of fast. When you guys did this, some of you guys threw much faster than this, so it's not that fast. The height of the ball as a function of time can be modeled by this function. The height with respect to time is given with by negative 16t squared plus 48t plus 64. So we have control over these two numbers, how fast we throw, and we also have control over where we start, the height, the initial value, the initial height. We don't have control over gravity. Gravity just, we don't have control over that. Okay, so let's see. What is the height? The reason why the height is a 0, I'm sorry, the height of 0.64 is, let's see. So we're going to use this function. Everywhere we see a t, we're going to replace it with the number 0. So negative 16 times t squared plus 48 times t, and then plus the initial height, 64. So anywhere we see a t, we're going to replace it with 0. Okay, so that's 0, and that's 0. So 0 squared times negative 16 is 0. Okay, so anything times 0 is 0. 48 times 0 is 0. So 0 plus 64. That's why the initial height at 0 seconds is right where we started. So height of 0, the height of 0 is just equal to 64. Okay, what about the height after 1 second? All right, so anywhere you see a t, we're going to replace it with 1 second. Okay, so I'm just going to copy this and paste it right here, whereas it's h of 2. Actually, this is h of 1 second. So the height after 1 second, let's see. So instead of instead of replacing it with 0, I'm going to replace it this time with 1. Okay, so anywhere I see a t, I'm going to replace it with a value of 1. Okay, so let's see. 1 squared, that's 1 times 1 times negative 16, it's negative 16. 48 plus 1 is 48, and plus 64. All right, so the height at 1 second is going to be 48 plus 64. 48 plus 64 is going to be 12. We carry the 1. So this 5 plus 6 is 112. So if there was no gravity, it would be 112. But I got to subtract gravity that's pushing it down. So I'm going to subtract 16. All right, so 16. All right, so 6 to 12 is going to be 6. And I already said 12, so this is going to be 10 minus 1 is 9. So the height after 1 second, it's going to be about here, 96. So it's going to be 96 feet above the ground. The height after 1 second is going to be 96. All right, what about the height after 2? Well, it's also 96. So that's probably when it goes up and then it's going to come back down. So that's going to be here. It's going to hit like 64 at the beginning and also when it's coming back down. So the height after 2 seconds, it's going to be the following. So let me just copy and paste it. All right, so we don't have to write it again. Okay, I could. All right, so the height after 2 seconds is going to be right here. All right, so anywhere we see a 1 is going to be replaced with 2. All right, so we're going to replace it with the value of 2. So the height after 2 seconds, so this is going to be 2 times 2 is 4. We always do the parenthesis or exponent first, times 16 or negative 16. Negative 16 times 4, I've done this before, and I remember it's 64. Okay, and 48 times 2, 48 times 2 is 96. So I'm going to add 96 plus 64. When I add 96 plus 64, so 6 plus 4 is 10, and I carry the 1. 9 plus 1 is 10, plus 6 is 160. But I have to subtract gravity. Okay, so I can't just throw 48 miles per hour in 2 seconds. I'm sorry, 48 miles per second. In 2 seconds, 96, plus the initial height of 64, which is up here on top of the building. I got to subtract gravity. So I have to subtract those 64 feet. So 4 to 10 is 6. And it's going to be 15 minus 6. So 15 minus 6 is 96. Okay, so the height at 2 seconds is 96. Okay, so this is probably the hardest one, the hardest question that you have. All right, this one, the reason why is 56.8. So also you're being asked, there's also a ball that's being thrown with an initial velocity of 22 meters. Okay, so this is just like the other one. The height is represented by this quadratic function. This is gravity, and you have control over how fast you throw and the initial height, which is 5.5. Okay, all right, so we're being asked, what's the height after 3 seconds? All right, so let's see. The height after 3 seconds is negative 4.9 times 3 seconds plus 5.5, I'm sorry, plus 22. So we threw 22 meters per second. So we're being asked about 3 seconds. And that plus 5.5, the initial value of 5.5. All right, so this is going to be 9 times 3 is 27. I carry the 2. 4 times 3 is 12. Plus 2 is going to be 14. So 14.7. And this is minus. All right, so now we got to add 22 times 3. That's 66. So I'm going to add 66 plus 5.5. 66 plus 5.5 is 71.5. Okay, so the height after 3 seconds is 71.5 minus 14.7. So let's subtract 14.7. 0, 0, 0, 0. So 15 minus 3. All right, this is going to be 8. All right, we did borrow 1. All right, so this is going to be 6, and then we borrowed 1. We went to 11. All right, so this is going to be 6. So 6 minus 1 is 56.80. Okay, so on your test, you're not going to have decimals. Okay, all right, so the domain is you're going to be referencing this x-axis. Okay, so a reasonable domain, so this is the height of somebody throwing the ball, and it touches the floor after 4.8 seconds. So the domain is from 0 to 4.8. So the domain, we reference the x-axis. So it's from 0 to 48. The range, what's a reasonable range? So that's the y-axis. That's this axis. All right, so the lowest point is here when it touched the floor. The height was 0, and we always write the smallest number first. And how high it went all the way to 30. So we reference this y-axis. That's the range. So the range of values is going to be from 0 to 30. Okay, so that's question number 17. Also this one, the range. The range is we're going to reference the x-axis. I'm sorry, the domain is the x-axis. The domain is the x-axis. So the domain is from -6 to 0. Okay? And we're including 0. We're not including -6. The range is the y-axis. We're going to reference this y-axis. Okay, so the lowest point is here, but when we reference the y-axis is 2 to 5. We write the smallest number first. So the range is between 2 and 5. There's a little dot on 5, so we're including that 5. Okay, so number 20, you're being asked, I'm sorry, number 19, the daily cost of hiring a plumber, that's the Y, how much it costs, to work X hours on a repair project can be modeled using a linear function. The plumber charges a fixed $80 plus $45 per hour. The plumber works maximum of 8 hours per day. So for 1 day of work, what is the range? Okay, so how much are you going to pay, the range of the function of the situation? So the range is the Y. Okay, so we could pay 80, or if he's there for 8 hours, it's just going to be 80 plus he works 45 times 8. So actually the range is not going to be this is the domain. So we're not talking about the domains, we're talking about the range. So the range, we're going to pay between 80 and 45 times 8 hours. So 45 times 8 is 440. So we're going to pay between 440. The range is going to be between 80 and 440. That's why it's B. Okay. All right. So question number 20. All right. So you're being told that the domain is 8 units long. So from here to here is the domain is 8 units. And then you're being told that the range is 6 units tall. So from here to here is 6 units tall. We don't know what R is, but we know that it's 8 units away from -3. Okay, so this point here is -3. So we're going to go to the left 8 units. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. If I go 8 units, I'm going to end up -3, -4, -5, -6, -7, -8, -9, -10, -11. So R is -11 because you're being told that the range is 11, or I'm sorry, 8. Same thing for the range. So the domain is 8, the range is 6. So this lowest point here is -4. So we got to go up now. If this is -4 and then the range is 6 units away, so let's see, 1, 2, 3, 4, 5, 6. So we're gonna go up. So when we go up on the y-axis, we're gonna go up -4, -3, -2, -1, 0, 1, and 2. So z on that one is going to be equal to +2. Okay, so this is what gave it away. The domain is 8, and then the range is 6 units. Okay, all right, guys. So good luck. The last one is so we do the vertical line test. So whenever they touch more than one point, that's not a function. Okay. All right, guys. So these are all the ones that are functions. All right, guys. So good luck on your test. Bye.